use the Gaussian elimination method to solve the given system of equations. So you have the system of equations here. X plus 3y plus 2z is equal to negative 3. 2 minus y, no, 2x minus y minus 3z is equal to negative 8. 5x plus 2y plus z is equal to 9. I'm going to ask you to pause the video, write this down, and solve it. Now, I have worked it out before, and my answers were x is equal to 2, y is equal to negative 3, z is equal to 5. I want you to work it out step by step. Ensure you understand all the steps to the point where you get this answer. Make your attempt. Don't use any help. Don't ask anybody any question. Work it out based on your own knowledge, skill that you've been practicing. Don't use any AI to help you. Don't use any notes. Just work it out. Even if you don't get these, it's good to practice. So go ahead. Okay, so you're finished. Did you get these? Remember, if you didn't get these answers, well, it's either I made a mistake, or what I would suggest you do is practice. Try again to see if you made any mistake. Alright? So, let's look at this. We write in matrix form. You have 1, 3, 2, and you have x equals 3, 2 is 2, negative 1, negative 3, y equal negative 8, and 5, 2, 1, z equals 9. So this is matrix form. So notice 1 times x plus 3y plus 2z equals 3. 1x plus 3y plus 2z equals 3. Alright. Same thing here. 2x minus y minus 3z is equal to negative 8. 5x, which is here, plus 2y, which is here, plus 1z, z equals 9. Now, you write them in the augmented matrix. You have the numbers 1, 3, 2, 2, negative 1, negative 3, 5, 2, 1. Vertical line, 3, negative 8, 9. You don't bother with the x, y, z. You know that they're supposed to be there already. Now the equal sign, you just write them in this form. Now, what you're going to do is somewhat similar to multiplying one equation by a number. You get the same x, same y, same z, and you add or subtract to eliminate. You subtract them, it is the same number. X, you subtract them, it is the same number, and the sign is negative. That is different, whatever it is. You remember when you solve the quadratic equations using elimination methods, it's the same thing. But in this case, you avoid all the mix-up and confusion with the x, y, z, because you're working only with numbers. So now, the aim is to turn this to a 0, then get this one also to a 0. So you have 0 over 0. Alright? And when you do that, you have some stability, some level of stability with the two zeros. So, what you do, turn the 5 into a 0. Turn row 3, column 3, the element in row 3, column 3 to 0. Alright? So how do we do that? We could do, right? We have to get a 5 over this 5 and subtract them to get 0. So what we can do, this one here, let's multiply it by 5. So 5 times row 1 will give you a new row 1. So let's do that. We're going to change row 1. So 5 1 5, 5 3 is 15, 5 2 is 10, 5 3 is 15. Alright. We'll only change row 1, we won't change any other row. So we still have our 2, negative 1, negative 3, negative 8, and our 5 2 1 9. Now, what we'll do is subtract these. Say row 1 minus row 3 will lead to our new row 3. So we'll change row 3 alone now. So in row 1 we still have our 5, 15, 10, 15. In row 2 we still have our 3, negative 1, negative 3, negative 8. But now we say 5 minus 5. This will be 5 minus 5, which will give us 0. So we have our 0 here. 15 minus 2 is what? 13. And 10 minus 1 is 9. 15 minus 9 is what? 6. Alright, so that's what we have. Now, this would be like equation 1 by 5, and then equation 1 minus equation 3. Right? Somewhat similar to that. If we multiply this by 5, we get 5x, and then 5x minus 5x would be 0x. So we get a new equation with a 0. But that will be quite confusing and mix up with all of those x's and y's and equation 1, equation 2, equation 3, equation 4, and so on and so forth. And we might have equation 5, equation 6. So this is much neater. Gaussian elimination method. Alright, so you see, we want, our aim is to get 0, 0, and a number. This number would be z, so we know exactly what z is. The thing is, we don't want to try and get a 0 here yet, because if we have a number over 0, right, we're going to have to add a row to a row. So when you add a number to 0, you don't get 0 again. That 0 will disappear, and we don't want to use this, we don't want to lose the 0. So what do we do now? Let us say row 1 times 2 gives you a new row 1. Let's do that. Row 1 by 2. 5 2 is 10. 15 2 is 30. 10 2 is 20. 15 2 is 30. Alright? We have back our 2, negative 1, negative 3, negative 8, 0, 13, 9, 6. After that, let us have our row 2 times 5. Give us our new row 2. So we change row 2. Row 1 remains the same, 10, 30, 20, 30. Row 3 remains 0, 13, 9, 6. But we'll multiply our previous row 2 by 5 and write the new row 2 here. 2 5s 10, negative 1 5, negative 5, negative 3 5, negative 15, 8 5, 40, negative 8 by 5, negative 40. Okay. We could have done both of them one time, you know what? We want to avoid the mix-up and the mistakes that they might lead to. So now we have the opportunity to make a 0 above the 0. We're going to say row 1 minus row 2 gives us our new row 2. So we're going to change row 2. So we make row 1 remain 10, 30, 20, 30. Row 3 remains 0, 13, 9, 6. But row 2 now. Row 1 minus row 2. 10 minus 10 is 0. 30 minus negative 5 is 35. Now don't make the mistakes of saying 30 minus negative 5 and you use 30 minus 5 is 25, or 30 minus, and then you see negative 5, you get down to negative 35. Is 30 minus negative 5. Sometimes it's good to write them down. 30 minus and then negative 5. And you take your time and see that 30 plus 5 is 35. So you don't make a mistake, right? Alright. 20 minus negative 15 is the same as 20 plus 15, which is 35. Then 30 minus negative 40 is the same as 30 plus 40, which is 70. Alright? So now you have 0 over 0. So now the thing is, no matter what you multiply row 2 by and row 3 by, you still have the 0 remain. And no matter whether you add or subtract row 2 and row 3, 0 plus 0 is always 0, 0 minus 0 is always 0. So you're not going to lose these zeros. Nice. Alright, you want a 0 here now. The 13, you want it to be 0. But it's kind of awkward working with these big numbers, right? These are very big numbers. You don't want to try and work with these very big numbers. So you see, you could divide row 1 by 10 to get your new row 1, right? Row 1 divided by 10 leads to a new row 1. So 10 over 10 is 1, 30 over 10 is 3, 20 over 10 is 2, 30 over 10 is 3. Nice. What about, you know what? You see the row 2, we could say row 2 divided by 35 give us a new row 2. Alright? You see it? So 0 over 35 is 0, 35 over 35 is 1, 35 over 35 is 1, 70 over 35 is 2. Much smaller numbers now. They have 0, 13, 9, 6. See what? So what happened a while ago? Right? Now, we run out of scrolling space, but we have a little space below here. So let's turn this 1 into 13, and then that 13 minus this 13 will give you a 0. So So we say row 2 times 13. Sometime on other videos or books you will see 13 row 2. 13 times row 2. I like to put the multiplication sign. 13 times row 2 will give you a new row 2. Sometimes they even mix it up and say 13 row 2 minus row 3 give you a new row 3. But I don't like to mix up too many steps like that. It causes confusion and you might make mistake. So you have 1, 3, 2, 3. 13 times row 2. 13, 0, 0. 13 ones 13. 13 ones 13. 13 twos 26. And then you have row 3 remains as it is. Okay. Now we have run out of scrolling space, so let's draw a line upward and work on the right hand side of that line. Alright. So what do we have here now? It is 1, 3, 2, 3. So we have the matrix here. 1, 3, 2, 3. What else happened here now? 0, 13, 13, 26. 0, 13, 13, 26. 0, 13, 9, 6. 0, 13, 9, 6. 0, 13, 9, 6. Okay, so that's what we have working with now. Now, we want to change row 3. Right? So row 2 minus row 3. I didn't say row 3 minus row 2 because row 3 has smaller numbers. I don't want too many negative. So I use the bigger number minus the smaller numbers. Row 2 minus row 3. Row 2 minus row 3 gives us our new row 3. So we're going to change row 3 alone. So I have 1, 3, 2, 3. 0, 13, 13, 26. Alright. Row 2 minus row 3. 0 minus 0 is 0. 13 minus 13 is 0. 13 minus 9 is what? 9, 10, 11, 12, 13. That's 4. 26 minus 6. That's what? 20. Alright. Good. Now, we have it in this form now. Some triangular form like this. So now that we have it in this form, let's see if we can get some smaller numbers to make life easier. Row 1 is already in smallest number. So row 2 divided by 13 will lead to our new row 2. And row 3 divided by 4 will lead to a new row 3. Alright. So row 1 is alright. 1, 3, 2, 3. Row 2 divided by 13 we have 0. 13 over 13, 1. 13 over 13, 1. 26 over 13, 2. So we have 1, 1, 2 there. And then 0, 0. 4 over 4 is 1. 20 over 4 is 5. Nice. So that's what we have there. Now, what we have what we're going to do here, based on what we have already, we rewrite from matrix form back to equation form. So we have 1x plus 3y plus 2z. I would like to put a line through my z because I don't want to mix it up with 2, equals 3. 0x plus 1y plus 1z is equal to 2. 0x plus 0y plus 1z is equal to 5. Nice. You see these zeros, 0x, 0y. Could just leave them out, erase them. You don't have to have them. So we have it like this now. Now it's clear that z equals 5. Z is equal to 5 based on row 3, right? Now if z is equal to 5, we substitute in row 2. Y plus 5 is equal to 2. So what is y? Y is equal to 2 minus 5, which is negative 3. See that? Now we know that z is 5 and y is negative 3. We substitute those in row 1. So x plus y, which is negative 3. Oh, it's 3 times y. 3 times negative 3 plus 2z is 2 times z is 5. 2, 5 equals 3. Then we say x minus 3, 3 is 9 plus 2, 5, 10 is equal to 3. X is 3 minus 10 plus 9 is equal to negative 10 plus 9. So we have 3. Negative 10 plus 9 is negative 1. 3 minus 1 is equal to 2. Okay. So, as a summary, solution. X is equal to 2. Y is equal to negative 3. Z is equal to 5. Alright? So, that's what we have there. If you didn't get it earlier, I want you to write down the question. Again, write it down and try it again without looking back at any notes. So, I will see you in the next video.